So this is an example of a genetic disease that biologists sometimes figure out within families. So this one will deal with Canavan disease. And so what we know about the disease is that it's non-sex linked, meaning that it's not going to involve your X and Y chromosomes. And then it's this inherited condition, meaning that you can pass it on to your offspring or your children. So the question that they ask us is, how can an unaffected man and an unaffected woman produce a child with Canavan disease? From this, we can deduce that because it's inherited and because they're unaffected, we can say that the normal allele for this trait, Canavan disease, would be dominant, and the recessive allele would be the Canavan disease allele. So if you're homozygous recessive for the trait, you'll actually have the Canavan disease. So because we know that they're both unaffected, we know that they both can be homozygous recessive. So we actually know that they both have to be heterozygous dominant for the trait. So they're both big A and little a. So how do we find out the offspring? Well, we'll put them on a monohybrid cross, and so we'll cross parent 1 and parent 2, and you notice how we get a total of 4 offspring, meaning that each of these categories have a 25% chance of being expressed within the offspring. So we notice that the first one will be normal, so we call these phenotypes, what they actually express. The first one will be normal, the second one will be normal, they won't have the disease, but they'll be a carrier for it, so they carry an allele, just like their parents. Another one will be identical to the one previously said, and then we have one with a double recessive allele. We call that a homozygous recessive organism. So this one will be Canavan disease. So that's how we answer the question that how can two parents who don't have the disease pass it on to one of their children?